should help you out with the watermelon worksheet you guys have. This is all when you're trying to find the equation in standard form of a parabola when they give you either the vertex or the roots or zeros or something like that. So we know here they're asking us to find the equation of a parabola with a vertex of 3, 4 and passes through the point 5, 12. We know the vertex form of the quadratic equation is y equals a x minus h squared plus k, with the vertex being h, k. So, first thing we're going to do is plug in h and k into this form. So we have y equals a x minus 3 plus 4. This gives us part of it, but we don't know what this a is. This a would represent the skinniness or wideness of the parabola. We don't know that until we take into account this 5, 12. That tells us where it's stretched or squished in. So what we have to do to find this a is plug in this coordinate x, y into the x and y. So this equation now turns into 12 equals a 5 minus 3 squared, plus 4. This gives us an equation with one variable, just a in it. We should be able to solve for a using everything you know how to do. So 12 equals a, we have 5 minus 3, which is 2, squared, which is 4, plus 4. If I rearrange that a little bit, that's 12 equals 4a plus 4. Should be able to do that with no problem. Minus 4 to both sides. We get 8 equals 4a. Divide by 4, and a equals 2. Now, that's only the first step of this whole process. That just gives us a. That tells us that up here, where I have my a up in the original vertex form of the equation, right here, that a is going to be a 2. So now, second step of all this is to go back and take this equation. Got 2's in green. We have y equals, instead of a, we have a 2 x minus 3 squared plus 4. Now we can rearrange this whole equation into standard form, which is ax squared plus bx plus c. So, starting with our whole PEMDAS order of operations, we're going to square the x minus 3. That's just a FOIL problem. We get x squared. That's first. Outside is negative 3x. Inside is negative 3. That gives us negative 6x plus 9. So, carry down the 2, carry down to plus 4. This is where we're at right here. A couple more steps. We need to distribute the 2x squared minus 12x plus 18, and then carry down our plus 4. Combine like terms here. We get y equals 2x squared minus 12x plus, plus 22. There is our standard form of a quadratic equation that passes through 5, 12 with a vertex of 3, 4. All right, second question. This is when we're trying to find the equation of a parabola given the two roots and a coordinate that it goes through. So we're going to start with the factored form of a quadratic equation, which is using our two factors here, x minus p and x minus q. But we also have that, I guess you can think of that like a GCF or whatever the A is that makes the parabola skinny or wide. They give us in the problem our two roots, our p and our q. We'll call that p and we'll call that q. It doesn't matter which order you use them. We're going to plug those into p and q. So y equals a x minus negative 3 will turn to plus 3, x minus 6. So those are our two factors. We still don't know what this a is yet. We could have an infinite amount of parabolas with those two roots, depending on how they're stretched or where the vertex is. So now we need to plug in the 5, negative 4 in for the x and the y in order to find this mysterious a here. So y is negative 4. Negative 4 equals a, or x is 5, so 5 plus 3, and 5 minus 6. I can now solve this big equation for a because I only have one variable a in there. 5 plus 3 is 8. 5 minus 6 is negative 1. So I have negative 4 equals a times 8 times negative 1, which is negative 4 equals negative 8a. Divided by negative 8. A equals not 2, 1/2. So this parabola is going to be stretched a little bit wider. I'm going to use that a wider because that's a smaller than 1. I'm going to use that a to now go back up here to this version of the equation and plug in my a for 1/2. So, step 2. Now that I found a, y equals 1/2 x plus 3, x minus 6. I need to rearrange this to standard form now. Standard form again being ax squared plus bx plus c. So using PEMDAS, I'm going to multiply. I'm going to FOIL these two things first. It doesn't matter which order you multiply in. You can multiply the 1/2 times this binomial or any order. I'm going to FOIL first. I find that easiest. X squared. Outside is negative 6x. Inside is 3x. If I combine those like terms, I get minus 3x. And the last is minus 18. But I got to carry this 1/2 down there. Last thing I do is distribute the 1/2 into the parentheses, so I end up with y equals 1/2 x squared minus 1/2 times negative 3 would be a 3 over 2 x minus 1/2 of 18 is 9. There is our standard form of a parabola with the roots of negative 3 and 6 that passes through that point 5, negative 4. If I wanted to go graph this in Desmos to check it or on my calculator to check it, I could do so. Good luck.